Alright, here we go. Section 2.7. This is that review worksheet thing I gave you to do. And start with number 2. Let's see, 2x plus 4, or 28x, sorry. 28x plus 4 is greater than 4 times 6x minus 7. Alright. What do we want to do? We don't want it looking like this. What do we want it to look like? Alright, well, in this case, greater than, right? Greater than 0. So we need to move all this stuff over here. Probably the best way to do that, you could do it a couple... I'm looking at this, I'm saying, look, you could actually, if you wanted to, this is probably not the, quote, traditional way of doing this problem, but I'm looking at this. See, I see a 4 here, right? I could divide this side by 4, divide this by 4, and this by 4, couldn't I? If I wanted to. Alright, so that would give you what? 7x plus 1 is greater than 6x minus 7, and then get rid of the 6x, get rid of the 7. If you wanted to do that. Alright, if you don't, you probably looked at this like that, right? Yeah, so let's just do it that way. That's I would call it, I guess, a more of a traditional way of doing it. Alright, so what do you got? 24x minus what? 28. Okay, subtract 24x from both sides. That'll get rid of this. Subtract 24x from this. That gives you 4x, correct? Added 28, added 28. 28 plus 4 is 32. Greater than 0. We good? Alright. And so really, this is not a product of two things, right? So we're not going to set it equal to 0. Remember we did that? We set it equal to 0. We don't have to do this on this one. This is linear. So I can just solve for x here, just like a normal solve for x. So actually, you know when I said put everything over here on the left-hand side, I really didn't have to do that, did I? I was thinking some of the harder ones. So you really didn't have to put everything over here. In fact, yeah, let's just subtract a 4, right, and do that. So that would be greater than negative 32. Right, that's better. Okay? Yeah, I don't know. For some reason, we've been doing that the last couple days, and it just kind of popped in my head. So let's divide both sides by 4. So x is, I'm sorry, x. I wrote 4, but I said x. So x, there we go, is greater than, divide this by 4, and what's that? It's negative 8. But how do we write it in, well, I tell you what, let's graph it first. To me, it's a lot easier to graph the thing and then write it in that interval notation. Have you found that to be true? Alright, so where are we? Greater than negative 8. So negative 8 would go right here, right? And it's greater than, so let's put a couple numbers in here just to see where we're going. Okay, so it's greater than negative 8. It's open, right, because it's not or equal to. So, yeah, let's do this in a different color. Right, so we're going to put a parentheses at negative 8, and it's going to go greater than, so it's going to go to the right. And then we just basically do this. Like that. Alright, so that's basically what it is. That's shaded in. You understand that, right? Okay, so that means shaded in. So it's a parentheses here, shaded in right there. So how would we write that in interval notation? Well, it basically comes right from this, doesn't it? Starts at negative 8, and parentheses, right? And it goes to what? It goes to infinity. That's right. Open at both ends. Infinity's always open. This is open because it's not greater than. Or, I'm sorry, it's not or equal to. It's only greater than. That's what I meant to say. Right? Not so bad, is it? That was the easiest of all these problems. Would you agree? Yeah, definitely. All right. So let's take a number. Look at number 4. Number 4, a little bit of a twist to number 4. 4 times 6 is 20? Is that what you said? Yep. Yep, it would not be. Alright. Number 4. Okay, this is a little bit different, but actually pretty close to what we just finished doing. Oops. Greater than or equal, forgot that. 4x minus 4. Greater than or equal to 6. Alright, well look, here's x. It's in the middle of those two things, isn't it? Usually it's just on the left side or the right side. Now it's in the middle of two things. So we basically do the same thing, except instead of just adding it from here and then to another side, you're adding it here and to two other sides, if you want to think of it that way. Agreed? So we get rid of the 4 by adding a 4, but look, you got to add a 4 to this side and add a 4 to, so you're adding it 3 times. Agreed? Now that doesn't change your inequality, does it? Alright, when you add something, so what do we get here? We get a 0 that's greater than or equal, that canceled out, that's a 4x, and that's greater than or equal, and that's a 10. Right? Divide everything by 4, so we divide both of these by 4 as well. So that's still 0, greater than or equal, that's an x because the 4's cancel out, greater than or equal, just reduce it. 2 goes into both of those, 5 and 2, right? So we just leave it 5 over 2. But what does that look like on a graph? So here's our number line. What are our two numbers? 0 is the smaller of the two numbers. 5 halves are 2.5, right? So if that's 2 and that's 3, 5 halves would be right here, wouldn't it? 2.5. So put a 5 halves right there. Now it's greater than or equal to, correct? So if it's or equal to, what do we do? Brackets, that's right. So we put a bracket right here and a bracket right here. And it's everything shaded where? Right. See, watch. X is less. Oh, no. You know what? They wrote this wrong. I think they did. I'm almost positive. I can't believe. I mean, according to the answer that they give you, okay, that's what I'm going by. According to the answer that they gave you on the answer sheet, they wrote this wrong. And we've gone through that before, haven't we? So really, they wrote it less than or equal than. I think they made a mistake by putting greater than or equal to. Because usually when you have something in between like that, you don't usually put the greater than symbol. I should have caught that right off the bat, but I didn't. Sorry. But anyway, I think they really should have written it less than or equal to. So according to the way they actually wrote the problem, these things would be going out, right? They'd be going out this way and out this way. But according to the answer I gave you, that I read off, the answer key made for me, it's all this stuff shaded in between. So if it's shaded in between, it should be written like this. Okay? That should be less than or equal. That should be less than or equal. Alright? Sorry about the confusion on that, but I didn't realize it until we got down to the end. So that should be shaded like that. So that's what it should. That's what your graph should look like. Alright? And how would we write this in interval notation? Well, it's pretty easy. It's basically the same thing as this is. We just don't have a number line on it, basically. So bracket, 0, comma, 5 halves, bracket. That's your answer. Well, both of them, because they ask you to do both things, right? Graph it and write it in interval notation. Does that make sense? Now, again, if it was written like this, you know, don't, like if it was on a quiz or a test, don't assume, oh, that's one of those, they probably wrote it wrong, so it should be like that. Nah, don't do that, because I'll have taken, right, I would have, I made up my own answer key, right? So I know if it was written incorrectly or not. What I read off to you was just taken straight from the computer program, right, when they generated the answers. Alright, we good with that? Oops, let's go back up here and see what problem we had to do. 7 and 11. Did you notice all the 7-Elevens closing? There's like 2 7-Elevens that, not all of them are, but quite a few. There's one on Basin Road, which I went to for years and years and years, and it closed. And then there's another one. I used to go to McCain High School a lot. I used to play basketball there, and every time we'd come back from practice or something like that, we'd always stop at that 7-Eleven. Now that's closed down all the time. So is the one on 40 still there, right? That wasn't 40 though. Towards Newcastle? There was never a...
Yeah, when 40 that's the Wawa across the street.
What are you talking?
Porter Road.
Oh, that's not way up 40. I thought you meant... Yeah, that's still
I've
there.
been way up 13 by a car wash.
Yeah, that one's still there. But you're saying...
Way up 13.
Oh, like towards Wilmington?
Yeah.
Oh, okay. And that's closed?
No, that's cool.
Oh, that's still open. Yeah, yeah, I know what you're talking about. Yeah, yeah. I know which one. Like there's a Radio Shack in that little shopping center and stuff like that. Yep. Okay. Good. Now we got our 7-Eleven opening and closing news down. All right. What? I can't remember which numbers we're doing. 7. Okay. Goodness. 7-Eleven, of course. How could I? That's how the stupid story started. Okay. 7 is x squared plus 5x is greater than or equal to -6. All right. This is definitely the one where we want to put everything on the left-hand side because it's a quadratic, right? So let's do that. So x squared plus 5x is gee whiz, plus 6, right, is greater than or equal to 0. So that's how we want to write it. Now, what do we do from here, though? We don't factor just quite yet. We do one little subtle difference. We set it equal, right? Because these are kind of like our points on our number line that we want to use. And that's what we want to find, where those points on our number line are located. So we actually set it equal to 0. It's not going to be my answer. It's not going to be my solution, but it's going to help me find the answer. So yeah, this one factors, doesn't it? Isn't it nice when it factors so easy? Yep, so x and x. What numbers? 3 and 2. All right. So solve for x. X is -3, and x is -2. Everybody good? So we put it on our number line. -3 would go right here, and -2 would go right here. Now what do we do? Is that my answer? No. Okay, so I got to figure out, remember I got 3 different sections here. I got everything to the left of -3, everything in between the two numbers, and everything to the right of -2. Yeah, try 0. It's always the easiest one. So where is 0 located? To the right. Now what am I trying to do? I'm trying to find out which numbers are positive, right? I'm trying to find which values are positive. So let's try 0, throw it in there, see if it comes out positive or not. So 0 squared, that's 0. That's 0. 6, positive 6. Is that greater than or equal to 0? Absolutely. So that means all these things over here are positive. What do you think the stuff in between is? Negative. What do you think the stuff over here is? It's going to be positive. So here's our solution. Do this in another color. Let's go orange. Orange and purple, does that go together? Doesn't seem like it would. Orange goes with everything. It says greater than or equal to. Are you watching? Greater than or equal to. So that means we're talking brackets here, aren't we? Yes? Okay. And then what do we do? Shade to the outside, right? So it's going to go this way. And it's going to go this way. Oops. Like that. Right? That's my graph for my solution right here. How do we write it in interval notation? Well, it starts at -infinity and goes to -3. So -infinity to -3. It's always open at infinity. This time it's closed at -3. Why is it closed? Because the or equal. Right? That's how we know. What about this? Put a union. And this starts off at -2 because we can include -2, and it goes to positive infinity. It's always open at infinity. So there's your graph, and there's your interval notation right there. On this particular problem, you need both of them. All right, make sure you read the problem carefully. Sometimes it only asks for the interval notation. Sometimes they just might say solve. They don't ask you to graph, but sometimes they will say graph and write in interval notation. Well, that was pretty straightforward, wasn't it? All right, as far as these kind of problems go, that was pretty simple, I think. They do get harder than that, don't you think? But not on this worksheet. Doesn't look like it, does it? Looks like it's pretty straightforward on this worksheet. All right, let's do another one. 11. Where'd they ever come up with 7-Eleven anyway? Anybody ever know that story? Anybody know where they came up with 7-Eleven? Why 7 and 11? Just because it sounds cool. We'll have to Google it after class, after we finish this lesson. I'd be interested to find out. All right, this one's a little bit more difficult, don't you think? Greater than or equal 5x. All right, well, we want a 0 on the right side, so we have to get rid of the 5x. So how do we get rid of the 5x? Well, not yet. What do we have to do to get rid of the 5x? We have to get rid of the whole entire 5x. So Just subtract a 5?
So you subtracted 5, 7 minus x. You put it over
Just
7
look,
minus
it's a
x.
simple question. How do you get rid of 5x? That's not how. You're telling me what to do. Tell me how. 5x. That's what I've been waiting for. No, it's not. You did not say. You kept on saying subtract 5. And I sat here waiting for you to say 5x. And you never said it. Aubrey, I didn't hear you. Okay? I didn't hear you say anything. So you got to speak up. All right? Subtract a 5x from both sides. That's how we get a 0 over here. All right. So let's do that. So 25x over 7 minus x. All I did was just rewrite that one. Now we're subtracting a 5x, correct? But I can't just put minus 5x. I have to write it so it has a common denominator. So the common denominator is 7 minus x. I can't just automatically put it, because that right there is not 5x, is it? So what do I have to do up here? Put a 7 minus x on the top as well. See, that's a nice, easy way to do common denominator, isn't it? Alright, see, because 7 minus x over 7 minus x is just a 1. 1 times 5x is 5x. So really, all I did right here was just subtract a 5x from both sides. But I had to put this on top and the bottom because I have to subtract it from this fraction, which has 7 minus x as the denominator. Alright, it's greater than or equal to 0 because I just subtracted a 5x. We good? Alright. I'm going to get rid of the little, because I'm going to plug some numbers in here a little bit. Alright, let's see. Let's do this. Let's write it over one common denominator. Let's figure out what's going to be on top. So right now we just have 25x. Now, we did this yesterday, day before, something like that. We did almost the exact same thing, didn't we? See, this is a minus 5x. It's a negative 5x. And it's being distributed through both of these. Most people get the first one okay, because they see the minus, so they put minus. They see 5x times 7, and they put 35x. Correct? But then a lot of people make the mistake by forgetting about this minus. It's still a negative 5x, isn't it? So it's negative 5x times what? Negative x. What's negative times negative? It's positive. What's 5x times x? 5x squared. Okay? Make sure that you understand that you're distributing this entire negative 5x through this thing. It's a very common mistake people make. Alright, let's clean this up a little bit. 25x minus 35x is negative 10x. So let's write it like this. Let's write 5x squared minus 10x over 7 minus x is greater than or equal to 0. Is this the same problem we did the other day? It seems like even the numbers and everything are the same. Do you remember? Seems pretty close. Well, anyway. Let's see what we can do. Now, I've got this thing set equal to 0. I've kind of simplified everything. If you wanted to, I guess you could factor out a 5, divide both sides by 5, but this will still work out fine. It was the exact same one, wasn't it? Okay, that's what I thought. Yeah, I thought we did this one. Anyway, we're doing it again. So let's watch. So we set this equal to 0, the top equal to 0, we set the bottom equal to 0. So 5x squared minus 10x equals 0. And then take the bottom, 7 minus x, set that equal to 0. Let's see what we get. What can we do here? We can divide both sides by 5. That would be easy, wouldn't it? You see that? That gets rid of that 5. Alright, and then look, factor out an x. This should be familiar. We just did this either yesterday or the day before. I can't remember. Let's keep going. Solve for x. X is what? 0, and x is 2, right? Because these are being multiplied together, right? So we set them both equal to 0. So x equals 0 and x minus 2 equals 0. If x minus 2 equals 0, then x must be 2. And then right here, just add an x to both sides, x equals 7. We actually get 3 different things. I'm not going to circle it because it's not technically my answer, is it? But these are the numbers I'm going to put on my number line. Alright? So let's put a number line. And let's go to there. Okay. Let's put those numbers on here. What's the smallest number here? 0. So put a 0 right here. Put a 2 right here, put a 7 right here. If this doesn't look evenly spaced, who cares? It doesn't matter, does it? I just want to see those numbers on my number line. I want to see you know, to the left, in the middle, to the right, all that kind of stuff. All right. So what do we have to do? This is what we're going to put some numbers into and see. We want to find which area is positive, which area comes out positive. So let's try an easy one. Let's try the one in between 0 and 2. What would be a nice easy number between 0 and 2? 1. Let's put a 1 in there. So 1 squared is 1 times 5 is 5. Minus 10 times 1, which is minus 10. What is that? It comes out negative, doesn't it? Now, I don't even care about the 5, do I? I just care that it's either positive or negative. So the top comes out negative. What about the bottom? What are we putting into it again? A 1. 7 minus 1 is positive 6, which is positive. So what's a negative divided by a positive? It's a negative. So any number between 0 and 2 is going to give you a negative value. So if you know this one's negative, what about the others? What about to the left of this? It's going to come out positive. Which one's this going to be? Positive. It alternates. Positive, negative, positive what? Negative. All right. What are we concerned about? We're concerned about the positives. How do you know that? Because I'm looking up here. It says greater than or equal to 0. That's a positive number. So my answer are just all the positive values of this. The blue looks nice. I'm getting tired of it though. Watch. What are all the positive values of this? It goes from negative infinity all the way to 0. Is 0 included? Why? It says or equal to. That's right. It says or equal to. So yes, it is included. So 0 is included, which means there's a bracket right there. It's always open at infinity though. All right. Union with where? Between 2 and 7, right. So I put a bracket here, 2 comma 7, put a bracket right there. There's no infinity on this one, is there? All right. Does that make sense? Actually, I lied a little bit. I actually didn't lie. Not on purpose. Lying insinuates that you did it on purpose. But I just made a mistake is all I did. Let's think about the denominator. We talked about this before. Can I include 7?
No.
Why not? That's right, because if I said x was equal to 7, if I said it was equal to 7, 7 minus 7 is 0, I can't divide by 0. So can I include 7? No, I cannot. So how do I get around this? I put a parentheses. That just means we get really, really close to 7. I just cannot include 7. All right, so that has to be a parentheses right there. Good thing I checked the answer, isn't it? All right, so if you have a denominator, just make sure that your values for x cannot equal something that makes the denominator 0. You get it? Now, x could be 0, right? Right here. But x can't be something that makes the denominator become a 0. So 7 would make this denominator be 0, so I cannot use it. So that's why I put the parentheses. It's open right there. And there you go. That's it. So, quiz tomorrow, which is Friday. And that's April 1st. And this is no April Fool's joke, okay? April 1. Yep. So quiz tomorrow. It's April 1st, but the quiz won't be a joke. There will be no... I'm not a big April Fool's kind of person, so I don't do that on my quizzes or tests or anything like that. What did I just say? Dude, listen to me. Oh my gosh. I just had a big talk about... I specifically said, we're gonna stop this. We're going to stop this, and I'm going to rewind it. Ryan Maynard just actually asked me if I was going to put an April Fool's question. It's on there. Too bad. It's on there. Yeah. His cell number is. His email is. All right. So there you go. All right. There you go. So... Yeah, you know how teachers say, "Oh, I've never heard a dumb. There's never a dumb question. Don't worry." That was an example of a dumb question. All right, enough of that before I get in trouble. Goodbye.